Assalamu alaikum everyone. I warmly welcome you all here and thanks a lot for giving me some of your precious time to hear out my presentation. First, let me introduce myself. I am Sahar Sagir from the Department of BS Biotechnology. And here is my presentation. My presentation topic is 2,4,6-trimethylaniline and it is submitted to Sir Dr. Hammad Majeed. So let's get started. The contents which I'm gonna covering in this presentation are introduction, its preparation method, the chemical, that how it's gonna be prepared, its properties, applications, that how it's used in our industries, etc., and a small overview of drugs catalyst. At last, there is conclusion and references, the websites, in case anyone gonna visit the websites to learn more about this chemical. So let's start with the introduction. 2,4,6-trimethylaniline is an organic compound with formula CH3C6H2NH2. It is an aromatic amine that is of commercial interest as a precursor to dyes. It is prepared by selective mononitration of mesitylene, avoiding oxidation of the methyl groups. The resulting nitro compound is reduced to the aniline. So let me first tell you what is aniline. Aniline is a colorless, oily liquid present in coal tar. It is used in manufacturing of dyes, drugs, and plastics, and was the basis of earliest synthetic dyes. Aniline is an organic compound with formula C6H5NH2. It consists of phenyl group attached to amino group. So the question arises that what are organic compounds? Organic compounds are compounds containing carbon-hydrogen bonds. And the building block for organic compounds is carbon because of its ability to catenate. The catenation is the ability of carbon which makes it the building block of the organic compounds. Here term is used aromatic amine. So what is aromatic amine? Aromatic amine consists of an aromatic ring attached to an amine. Generally in the word the aromatic refers to substance emitting pleasant or distinctive smell. In our daily life routine, we call it smell, like fragrance, aroma. And in chemistry, it's aromatic means the often organic compounds containing a planar unsaturated ring of atoms which is stabilized by an interaction of the bonds forming the ring. For example, benzene. Benzene is the common example of aromatic compounds. In this slide, a word is also used, precursor. Precursor is a substance from which another is formed. So the chemical here, 2,4,6-trimethylaniline, acts as a precursor from which another substances are generated or produced, like dyes, drugs, etc. Mononitration, the resulting nitro compound, avoiding mononitration. It is prepared by selective mononitration of mesitylene. So here a word mononitration is used. The mononitration is the act or process of modifying by introduction of one nitro group or one nitrate group. So moving on, there is nomenclature of this chemical. Preferred IUPAC name, 2,4,6-trimethylaniline is its IUPAC name. IUPAC stands for International Union of Pure and Applied Chemistry. And then there are other names for this chemical as well: aminomesitylene, 2,4,6-trimethylbenzene amine, mesylamine, mesidine, etc. Here is the structure of 2,4,6-trimethylaniline. As you can see, there are three methyl groups attached to benzene and one amino group, which makes 2,4,6-trimethylaniline. And it's a ring structure, as we have as we have learned about it in previous slide, that what are ring structures, benzene or aromatic compounds. So here is our ring structure, and it's the structure for 2,4,6 trimethylaniline. Okay, let's move on to preparation method. What are the preparation methods for this chemical? The invention relates to a method for synthesizing mesitylene. It first uses mesitylene and mixed acid to nitrate generate the 2,4,6-trimethyl nitrobenzene. Then it does catalytic hydrogenation to synthesize mestylamine, wherein the mixed acid is H2SO4 and HNO3 with weight rate H2SO4 75 to 80 backup and HNO3 20 to 25 backup. The catalyst used in this preparation method is nickel catalyst. Okay, so here the question arises that what is catalytic hydrogenation? Catalytic hydrogenation is the treatment with hydrogen in presence of catalyst, such as nickel, palladium, or platinum, any of the catalyst. Coordination chemistry. Here is another topic, coordination chemistry. Trimethylaniline is a building block to a variety of bulky ligands. Condensation with glyoxal gives the 1,2-diamine ligands. For example, glyoxal bis, a yellow solid that is synthesized by condensation of 2,4,6-trimethylanilene and glyoxal. The diamine is a useful precursor to popular NHC ligands. Okay, the coordination chemistry is a little. Here is a brief little. Here's a little overview of coordination chemistry. So, here bulky ligands. Trimethylaniline is a building block to a variety of bulky ligands. So, what are bulky ligands? Bulky ligands are used to control the steric properties of a metal center. Bulky ligands basically ligands have three types: anions, cations, and neutral molecules. And the condensation in chemistry is stands for a type of chemical reaction in which two molecules are combined to form a single molecule, usually with the loss of small molecules such as water. That two molecules combine together and one big single molecule is formed, and a small molecule is lost, such as water, and the overall process is known as condensation. So here the word glyoxal, maybe some of you know or some may don't know, but I'm gonna tell you about the overall topic. So I'm gonna tell you what is glyoxal. Glyoxal is also an organic compound with the formula C2H2O2. And glyoxal bis. Glyoxal bis is an organic compound. It's a yellow solid that is soluble in organic solvents. And NHC ligands, as you all know, because I have already told you about ligands, that ligands are used to control the steric properties of a metal center, and they have three types: anions, cations, neutral molecules. So what are NHC ligands? NHC ligands and heterocycle carbenes are electron-rich nucleophilic species in which the divalent carbenic center is directly bonded to at least one nitrogen atom within the heterosite. In this structure, as you can see, it's a structure in which a substituted 1,2-diamine ligand and an idealized metal complex is shown. 2,4,6-trimethylaniline preparation products and raw materials. So what are the raw materials for this chemical? So the raw materials in the preparation of this chemical are nitrotoluene, mesitylene. And the preparation products are acid blue 129, solvent blue 104, tracid light yellow J, and acid blue 80. Let's move on to its properties. What are the properties of 2,4,6-trimethylaniline? So its molecular formula is C9H13N. Its formula weight is 135.21. Moving on to its melting point. So its melting point is -5 degrees Celsius and its boiling point is 231.3 degrees Celsius at 760 millimeter mercury. Density. What is the density of 2,4,6-trimethylaniline? So the density of 2,4,6-trimethylaniline is 0.962 gram per centimeter per cube. And water solubility, immiscible. It's insoluble in water. Refractive index, its refractive index is 1.552. Vapor pressure 0.0627 millimeter mercury at 25 degrees Celsius. What is the form of 2,4,6-trimethylaniline? Liquid. It's a clear liquid. Color, and what's the color of this chemical? It's clear brown. It's a liquid, clear liquid, and its color is clear brown. And what's the storage temperature? That how can we store it for longer use, for long-term use? So the storage temperature is keep in dark place. You have to keep it in dark place. Inert atmosphere, you have to give it the proper atmosphere which it requires for longer use. Room temperature is better. Room temperature is better for this chemical. And here's a description. When heated to decomposition, it emits toxic fumes of nitric oxides. That decomposition affects it. Decomposition might be decomposition of it emits toxic fumes, which may not be good. So better be careful with this chemical. And applications. What are the applications of 2,4,6-trimethylaniline? How we are going to use it in industries, how this chemical is used in various things, etc. So 2,4,6-trimethylaniline is useful for the preparation of Grubbs catalyst. What is Grubbs catalyst? You all want to know, but I'm going to tell you about this in the next slide. Moving on, it is used as a precursor to dyes. I have already told you what is a precursor. Precursor is a substance from which another is formed. So it is a precursor to dyes. It acts as a precursor from which dyes are formed. 2,4,6-trimethylaniline undergoes condensation reaction with glyoxal to prepare glyoxal bis. It undergoes condensation. I have told you about the condensation process. What is a condensation process in chemistry? Let me tell you again that a condensation reaction is a type of chemical reaction in which two molecules are combined together to form a single molecule, usually with the loss of a small molecule such as water. So in a chemical reaction in which two molecules are joined together to form one big single molecule with the loss of any small molecule such as water, then the process is known as condensation. And glyoxal is organic compound, and glyoxal bis is also organic compound and is a yellow solid that is soluble in organic solvents. And mesethylamine, as you know, I have told about it, that it is another name for 2,4,6-trimethylaniline. It is used for the production of acid blue 129 dye, which is used in histochemistry studies. 2,4,6-trimethylaniline is used in the production of acid blue 129 dye, which is used in histochemistry studies. So what are histochemistry studies? Histochemistry study combines the techniques of biochemistry and history in the study of chemical constitution of cells and tissues. So the techniques in which we study both biochemistry and histology are the histochemical studies in which the students are going to know about the constitution of cells and tissues. 2,4,6-trimethyl-aniline also serves as a building block to various bulky ligands. Ligands have three types, as I told: anions, cations, neutral molecules, maybe, etc. A small overview of Grubb's catalyst. What is Grubb catalyst? How 2,4,6-trimethyl-aniline is used in Grubb's catalyst for the preparation of Grubb's catalyst. So Grubb's catalysts are a series of transition metal carbene complexes used as a catalyst for olefin metathesis. What is olefin metathesis? Olefin metathesis organic reaction is an organic reaction that entails the redistribution of fragments of alkenes by the scission and regeneration of carbon-carbon double bonds. They are named after Robert H. Grubbs, the chemist who supervised their synthesis. Several generations of the catalyst have been developed. Grubb's catalysts tolerate many functional groups. Functional groups like alcohol, alcoholic functional group, benzoic functional group. These are all functional groups, alkene, etc. Grubb's catalysts tolerate many functional groups in the alkene substrates, are air tolerant, and are compatible with a wide range of solvents. For these reasons, Grubb's catalysts have become popular in synthetic organic chemistry. Grubbs, together with Richard R. Schoch and Travis Trowen, won the Nobel Prize in Chemistry in recognition of their contributions to the development of olefin metathesis. Olefin metathesis as described earlier, it's an organic reaction that entails a redistribution of fragments of alkenes and regeneration of carbon-carbon double bonds, and it is here represented in this structure. Here you can see there is a structure containing carbon-carbon double bonds. There is hydrogen in it, and Grubb's catalyst is added in this reaction to carry out the reaction, and hence you can see ethane escapes as a gas, pulling the reaction to completion. And it's all because of Grubb's catalyst, because it entails the redistribution of fragments of alkenes and regeneration of carbon-carbon double bonds. And here is, as you can see, carbon-carbon double bond is formed. Here, but hazard summary. As you all know, that chemicals are dangerous. Chemicals are toxic. You can't play with them. You can't be friendly with them. They are toxic for humans or anything, like they are toxic. Hazard summary. So 2,4,6-trimethyl-aniline can affect you when breathed in. If you accidentally breathe in 2,4,6-trimethyl-aniline, it can affect you. Contact can severely irritate the skin and eyes with possible eye damage. In contact with the skin, if it gets intact with your skin, if it's get in contact with your skin or eyes, it may cause eye damage, eye problem, or skin damage. So better be careful with the chemicals. Breathing 2,4,6-trimethyl-aniline can irritate the nose and throat. If you breathe in 2,4,6-trimethyl-aniline, this chemical, so it can irritate, it can annoy your nose, your throat, because it is not a useful thing for humans. You can't just drink it or swallow it because it's toxic, it's dangerous for your health. Next, high levels may interfere with the ability of the blood to carry oxygen, causing headache, fatigue, dizziness, and a blurred color to the skin and lips. If you take in high concentration of 2,4,6-trimethyl-aniline, it can interfere with the ability of your body's blood to carry oxygen, causing headache. You may feel headache, you may feel fatigue, dizziness, blur color. Your skin may become blurry in color, and your lips also blur in color. And this condition your skin and lips becoming blur in color is known as methemoglobinemia. Methemoglobinemia. Higher levels may cause trouble, breathing, collapse, and even death. If you take in higher concentration of 2,4,6-trimethylaniline, it may cause trouble in breathing and collapse and even death. 2,4,6-trimethylaniline may cause a skin allergy. If allergy develops, very low future exposure can cause itching and a skin rash. 2,4,6-trimethylaniline can damage the liver. It's a very toxic chemical, so better be careful while using the chemicals in lab. Here are the references if you want to visit the websites from which I have taken my material. Thank you all for giving me your attention. If you all have some questions related to this, let me know in the comment section and I'll try to answer them. So that's all from my side. Thank you so much.